the current paradigm of agents or building software which interacts with external systems is like you have an LLM which is independent of the system, and then you're like shipping information between the context of the LLM, right? So you have running like React like agents like strategies, where in the prompt you're instructing it for tools and reflection and things like that. That's very much the current agent paradigm of around GPT-4 or around a big LLM, you're building your agent, right? The other thing which I've been thinking about, and that this basically came while I was working on the program repair thing, is like one of the things is when you're working on a concrete problem, you start to see how it generalizes to other things. It's like there is this notion of actually the data distribution the models are trained on are not things like text, where you're translating information into prompts and then feeding it the model, but rather you're packaging information up these packets of context, like the way function calling and tool calling have done with these tokens, and actually train your model to learn the distribution of the state, events, and action of your platform.
Welcome to Software Snack Bites. I'm Shomik Ghosh of Bold Start Ventures, and today we're excited to have Madhav Singhal on the pod. Madhav is an AI research lead and engineer at Replit, and in this episode, we're going to cover how Replit approaches AI-powered IDE workflows, the cutting-edge research that they're doing on models, and the future state for AI code generation. So welcome to the show, Madhav.
Awesome. Thanks for having me.
Yeah. So just, I guess to start off, let's go from the top. For people who don't know what Replit is, what does Replit do?
Replit is an end-to-end software development platform where anyone, absolutely anyone, can come and create and deploy software with AI assistance like throughout the way. So you just come in without any setup on any device, you spin up an environment, tell AI what you want to do, and you go from the process of idea to creation end to end super fast. And that's really our driving mission, is like, how do you from idea to software really fast? And yeah, I think that's the mission we've been in service for throughout all this time.
It's pretty crazy because what you're talking about is essentially taking on like a VS Code or something like that, right? Which people have used. It's widely distributed. Everyone's grown up through university using this sort of stuff, right? I guess is the crazy vision the fact that you guys are just doing so much stuff on the AI side. You've truly advanced things a lot faster than anyone else in the market, and so it's just making it a lot easier for people to understand how to use an editor.
Yeah, totally. And in fact, one of the funny things we talk about is almost we're competing with everybody. We're competing with the cloud platforms for development environments. We're competing with development platform products like Supabase and so on. We're competing with AI kind of for chatbots for coding. Everybody's using chat, so it's almost we're everywhere. But the entire magic is this entire combined native experience. And I think that's where the magic comes in, when you own the platform, where the platform is built from the ground up for this idea of how do you build software really fast. It's in the name REPL, right? It's this iterative process of the REPL approach to developing software. So yeah, it's just funny. We're everywhere.
Well, I love it, and it makes sense. So let's go to kind of the linchpin of that, which is AI. And whenever you start with AI, I think you got to start with data, right? Sure. Which is the kind of the engine behind it. And so when you're thinking about LLMs, do you consider data to be the primary bottleneck for you?
Yeah, let me set up this question a bit and how I approach this problem of data and bottlenecks generally, and then specific to Replit. So I think about data bottlenecks in three dimensions. One is just purely the volume, which is how much data can you get, right? It's about depending on the problem you're solving. The second dimension is the diversity and quality. For the problem you're solving, how much diverse data you can get and how much high quality, which is low errors, low noise, and so on. And the last thing is this important thing, which a lot of people forget, is the shape of the data. So is the shape of the data in the sense, is it just standard code files, which you just train a normal completion model over, or is it chat data? Is it planning data in terms of how models are user input about how they're thinking about building software, some error data, execution data, and so much more. And Replit is in this unique position because we own the platform from ground up of having a unique advantage in having in terms of data across all three dimensions. So we have our own user base, 25 million users plus, and so on. So we get this first dimension of data clearly sorted. We support every language, right? Compared to, for example, Colab, it just supports Python. So that there's a diversity question. The quality question comes down to, because of the fact that people are developing and running and deploying things, it's not just code put up on GitHub. It's actually code which has ran, for example, right? So you get this notion of like filtered through execution or implicitly in the data, which adds the quality because somebody's run it. So that's the first dimension, at least. The second dimension is okay. I'll take the shape first, which is the most interesting thing. Is like not only we just have code files to train on the platform, but we also have things about how users are interacting with chat to actually develop their software, how users are accepting or rejecting Copilot like completions. And more generally, we have this notion of every single interaction, every single keystroke, every single user event, every single IDE event. And those kind of things, which gives you this entire like landscape of data, which you can like build data sets out of to do something. So TLDR, not really a bottleneck. It's more, in fact, we just like, it's so much to deal with. And it's like, my job is basically about thinking about how you can leverage data in unique ways to create value for the user.
Okay, so let me ask that differently. So it sounds like, hey, volume of data, quality of data, shape of data, all of that is there. However, the problem, if there was one, was you actually have to choose for what model and for what use case is certain types of data most useful.
Exactly. It's like problem first. It's like, what problem are you trying to solve for the user? And then you come and look at this entire data landscape and you figure out, okay, I actually have the data to actually solve this problem in a unique way.
Yeah. When you talk about even just, someone saying yes or no to the Copilot generation, things like that, and then also the workflow, I mean, it sounds like essentially you're envisioning a future where it's not just, hey, code generation, but it's like there's some other stuff that's happening based off of that. So I guess like maybe talk a little bit about that vision.
Of course, yeah. And like, my mental model of like this, how LLMs have been used, like paradigms of usage is somewhat as follows. Like first you had completion, then you had this instruct/chat kind of way to use it, right? And then it moved on to tool usage, function calling, RAG, where LLMs are actually outputting some kind of program or like computation, which is then deterministically executed. And now you have this notion of agents, right? Which is like LLMs running in loops. So if you look at this model, the way we think about how our data is useful is across all these paradigms. Not only are like collecting data on just completion and so on, but you're also like, okay, how was the completion accepted, rejected? And then you can tune that part, right? Then you're collecting data on like, how is the user talking to chat while actually building the software with acceptances, feedbacks? Did the code actually run, whatever based on chat suggested, and so on, right? Third is, okay, how you're orchestrating tool usage across the entire Replit platform, how you're fetching data from your RAG index and so on, and that you have data about that as well as you tune. And then lastly is agents, which is like this. Replit has this unique, like, is this in a very special position because it has this, like, the kind of reasoning data sets and planning data sets which research labs are after for, we pretty much have it right there in like
natively
in the software development context, because you have users saying, I want to do this, plan comes, the user does XYZ actions, changes the plan. So you have this agentic data about how the user's actually interacting with other systems and actually building software end to end. Like, so that's like a kind of like a sneak peek into like how we think about data and like where things are going based on data.
Oh, everyone's jealous about all the all the first party data that you guys have.
Yeah,
but I imagine at some point, right? Like, especially with LLMs, right? We've now learned that like the more you scale them, the better they get, kind of. And so I imagine even from the Replit side, like there's no such thing right now as too much data. So yes. In that context, like, is synthetic data something that you think about at all? Is it useful to you or not really?
Yeah, no, that's a great question. And totally. So like we actually do, like we have the part one is getting all the raw data in, like you have users using the platform every day. And so you're collecting that data. But the second dimension to data is this notion of synthetic data, as you alluded to. And yes, it's actually pretty important. Synthetic data specifically is very useful when you're trying to induce certain kind of like task abilities in the model for which it's very hard to engineer data in the first place. So going back to my notion of data shape, there are certain kind of tasks you want to train model for where you don't have data immediately present in the shape you expect it to. And then those are the kind of places where we find synthetic data to be very useful. One big idea or caveat, right, is like how the public generally thinks of synthetic data is like, oh, you're generating the entire data set with a bigger model.
Mm-hmm.
And then you have this problem of mode collapse and so on, which is like, oh, like, can models actually learn if they're just like being generated, like trained on data? Can they actually achieve true generality? And our approach to this is slightly nuanced, which I think a lot of people have figured out now, is this notion of you actually want to, it's not about generating your data end to end synthetically. It's about seeding your data with real world use cases, or like how users are using it, and using synthetic or like using other models to generate the last kind of like 20% of what you need, or like actually rearrange data in the shape you want. So it's not so much of the full data set is generated synthetically, but it's about how you actually use these models, combine them with actual real world data, which has this wide distribution, and you build out data sets at scale and of shapes you want. And that's really the important lesson about how to use synthetic data. And we focus a lot on that, which is like, how can we augment our actual data across these dimensions I talked about earlier, augment them with synthetic data to actually create like product surfaces which are useful.
But just to dive a little bit deeper into that, so and maybe there's an example or something. Like, is it if so someone's typing up some code generation will give them something that presumably works. Would you say, like, at that point, for your own training and stuff like that, you would then set up a separate model to just like simulate like different types of code generation or something, and train it on that? Or I guess, like, what's an example?
For sure. So let me give you a very concrete example. So let's say, for example, in our user metrics, we observe that the rate of rejection for Rust code completions is actually lower than like the kind of bounds we expect, right? We're seeing this deterioration. And we see, okay, that's because some other crates are coming in where a lot of people are using Replit to build this kind of user-specific framework, library, or a crate, like in Rust, for example, to build it. What we can do then is we take a bigger model, which has perhaps seen a more latest model like Llama 3 or something like that, something open source, which allows us to do so. You actually, for that sub-distribution where your model is performing weakly, you generate with those same prompts, you generate the kind of expected completions, you synthesize those things. So your inputs are real world, but your outputs are synthesized, and then you fine-tune the model on that. So that's one very common example of how, for example, synthetic data is used by us and many other people.
Okay, got it. That makes sense. I want to move into something really cool that you guys announced recently, which was this program repair agent. And so just, kind of give us the backstory of it. How did it come about? How does training work for this? Like, there's a bunch of questions I want to ask around it, but maybe just first, if you start with the background.
Yeah, this is probably one of the most intellectually interesting projects I've worked on at Replit. And so let me set up the problem and like the motivation a bit. So the key insight we had was like when looking at our data on how people are using AI and like how people are using Replit is we focus on like, if this idea to software fast, you want to reduce the amount of friction they encounter. And so then friction can be in multiple different ways, like environment setup, but dominantly it's about where they're hitting like errors into while like writing code, for example. And we saw that Replit has this, like we have more than 200 million events per day of like people running into these static errors where like, they're writing code and like, type signatures change and, and it's this kind of thing where LSPs, which are the tools built for these solving these kind of problems, have like auto fix suggestions for only like, I think roughly like 18 to 20% of the use cases. For example, for Python, which is like a dominant language, only 10% of like their data distribution actually has like auto suggested solutions from classical tools. And we're like, okay, if you're getting 150 million events a day, and if you say 1 second per event, you're actually unlocking a huge amount of productivity, right? So that was like the kind of motivation. So it's like, if this is a unique product surface we should tackle because we're seeing a lot of this happen. The next thing is, in fact, we're in a special position to do this because we have this data about what users are typing, when are they hitting an error, what users are doing to fix it, right? Compared to like GitHub and so on, where you just have the static data of like what the final output of the code or an intermediate output of the code. Sure, you have commits for fixes and so on, but that's not even close to the kind of resolution which we have, right? So if you think about it, Replit is this entire stream of every keystroke, every user event, every IDE event happening, right? And somewhere there are some windows where user encountered a static error and they did some steps to fix it. And we're like, okay, if this is the problem you want to solve, we're in a very special position to solve it because we actually have this data, right, to solve it compared to like, having to like figure out how to get this data in the first place. Let's actually build pipelines to sample these sub windows of data, clean them up, and actually tackle this problem. And we took a very pragmatic approach to it. It's not like, oh, just throwing everything at it, like throw a lot of compute, throw a lot of data at it, which is like, actually, can we even do this in the first place? Because it doesn't really fit into a paradigm of existing pre-training or even like cleanly supervised fine-tuning, which is like, okay, how do we actually model the problem in the first place? And yeah, to TLDR, we had the problem, the motivation, and the kind of data we have. And then this last step, which is like we actually incrementally approached it and like kept testing it at different data scales, at different model scales, where we knew, okay, we can actually really do this, and it actually works pretty well. And so that's kind of like the background. It sounds a lot more messy, you people see the final output product, but that's how actually we think about it, right? It's like just thinking basics.
Okay, so tons of questions off of that. So first, I imagine like the Replit data team must be just absolute heroes, because even just to get the before error and after error, that means like you almost need to be logging everything in like a time series. So then you can.
Yeah.
Is that kind of what's happening? Like, is that how you?
Yeah, exactly. You're getting it exactly right. It's almost like you're reconstructing the state of REPL, and at any point of time, it's like you're playing back a video at any point of time. And so imagine the data lift about that.
That's
and
crazy.
the volume the volume we're talking about here is in like a couple of terabytes a day. Like it's a lot, and you have to build the kind of infrastructure to actually be able to sample in the kind of windows you want. We even do things like run the LSP again to verify integrity. We do crazy things like clock syncing, because you have like one disk here, like one workspace here, and how do you actually sync clocks to get states working? And so, yeah, in fact, the dirty secret of most machine learning projects is like 80% of the work, if done properly, is data work. And yeah, it's my team and the data team which actually like take this kind of and yeah, it took us a while to get that data, but you're totally right. That's what it is. It's almost like you're reconstructing REPL state at any point of time to get these kind of before after pairs and so on. And yeah,
that is a very cool problem to work on. Okay, next question within that. So you mentioned Python as an example, but obviously there's a lot of languages that run through Replit. Like there may be a Python specific problem versus a Java specific problem versus whatever. So are you training different models on each of those? Like how does that work?
No, that's a great question. And it's one of those kind of things which the answer changes depending on how you use, what are the constraints of your problem in terms of model size, inference cost, and so on, and also the problem domain you're working in. TLDR, our approach to this is to train a single model across multiple languages. We have continuously more again and again observed above a certain model size, you actually get transfer learning benefits of seeing multiple different languages. So that's a pretty well-known insight in the code world. At the same time, we do it incrementally. So right now we're trying to release for Python first, and that's simultaneously fine-tuning for JavaScript and TypeScript, because we get a sense of how is the model learning and behaving across these sub-distributions. And you tweak your data accordingly. Yeah, in summary, single model, we try to like go iteratively to get a sense of how the model is behaving over the entire expected language distribution and go from there.
So when you tackle something like this, right, you could train something on your own. You could rip down a massive model from any of the open source or proprietary ones, whatever you want to use, and then you could start to fine tune a lot more. Like, kind of, what's the best approach? Is it or what's the approach that you like to take? Is it start with the larger one and fine tune it down, or is it train your own, or how do you think about it?
Totally. So there are two questions. One is, do you pre-train from scratch and then you fine tune? And then the second is the model sizing question, right? So I have this mental model of this notion of latent shift, which is like, how much are you changing for your particular task and use case from what the model already knows? So for example, in this code repair case, there are models, open source models on release under Apache and MIT, which have been seen like 2 billion, 4 billion, 6 billion tokens of code, right? So they have implicit understanding of code, right? And they have an implicit understanding of what correct code should be if the pre-processing is done happen. And from going from that to this format of like, okay, if I have a wrong line of code, fix it, given this error, that's a less of a distance. So in my mental model is the less of this task or this latent kind of what the model's already learned shift is, the more you can rely on fine tuning. Versus if you're pre-training a model completely for, let's say, on a stream of CAD software clicks and things like that, then you have to pre-train from scratch because there's no like model which has inherently learned the distribution. So that's number one. In terms of model size, there are two big things which are important here. One is actually understanding your use case you're solving end to end, like almost in a systems design way, which is like, you have to do the napkin math. You have to do the estimates of like, okay, if I take a 1 billion model, how much will it cost to serve? If I take a 7 billion model, how much will it cost to serve? Compare that with the load distribution you're expecting. So it's this particular kind of instance of where the research is actually driven by very clear product constraints, right? And instead of like me trying to squeeze out as much performance of the model by taking a 33 billion model, which might not be cost effective to serve if you have 150 million plus requests a day. So that is a huge thing. And the second is an experimental way to do it. You always want to like check whether how does this thing even scale? How does this thing even scale with data size and model size? You design experiments in a way to say, oh, how much of a performance boost am I getting going from 1 billion to 7 billion to 33 billion? That gives you, and you use that to compare with the trade-off. So it's this systems approach plus actually doing the scaling like experiment to get like a good sense of how the model and the data is scaling for your problem. That's the combination, at least, we take.
Part of that right now is where the current state of the world is too, when you're using it. Now, if in the future, right, Meta, just rolls out like a Python specific model and then rolls out a Java specific model and so on and so forth. Like I guess this is more of a future state of the world. Like, do you envision in the future that there's going to be a bunch of small specific models on different things and you're just going to rip them down for various problems that you're trying to solve?
No, totally. That's a great question. And yeah, it's one of those things with machine learning is the future changes, or AI more generally, the future changes so quickly that it's very hard to future proof yourself. I've trained models which were state of the art for like 4 months, and then like, suddenly something else comes out, and,
Yeah, right.
and you learn a lot, right? And it's like a good feedback loop. I think one is you have to design experiments or the kind of artifacts you're producing in a way where they can take benefit of what's coming in the future. So for example, how I'm storing checkpoints, there are technical details like how my learning rate schedule is, or how am I actually like doing this thing called a learning rate cooldown and so on, so that I can pick up the same checkpoint. And if I get more data, somebody releases a better data set tomorrow, I can actually continue training on that. So there are like kind of technical decisions you make to keep open to like further fine tuning, adjusting data distribution. And secondly, of course, you have to build your infrastructure, your data assets, and so on in a way that if a new model comes out tomorrow, you can just plug and play it. I suspect my kind of prediction about these things is I think models won't be like language specific more so, because we talk about this like transfer learning effect, like like models trained on multiple languages will work, but task specific models will become very important. So I think a model which fundamentally is predicting environment configuration might be slightly and especially if it's a smaller model, right? The caveat is what we're talking about here is for smaller models it might look very different from a model which is like purely this like supposed to fix like LSP errors, because like the kind of data distribution that's might be slightly different. They might be stemming from the same base model, but the task is the thing which is going to delineate models more so than like languages or something like that.
People always talk about hallucinations. When you're talking about something like code, like you want to minimize that as much as possible because you don't want a junior engineer or I won't even say junior, or senior engineer either, putting in any sort of code. So I guess when you were doing this repair model, for example, this repair agent, do you think that by focusing on that narrow of a space, the hallucinations decrease significantly versus if you were doing like a broader code generation thing?
Exactly. And yeah, that's actually like the key insight, which is like the narrower problem you're solving, the more you can constrain it and reduce this notion of hallucination. So it's like if I'm purely fine-tuning the model for fixing LSP errors, and my entire data set is basically catered to that, I have less likelihood of hallucination versus if I'm training a general model. The other big insight there is how many tokens are you generating? The more tokens you're generating, the more the chances can be that you're hallucinating, right? So if you're generating like 1,000 tokens, you're more likely to hallucinate because you have this epsilon. Like it's a property of the autoregressive models, which also, but more generally, just like, oh, you have larger space to make errors versus like, this code repair model where we're actually methodically suggesting like minimal amount of diffs, which reduce hallucination, increase precision, and at the same time make up for a better user experience.
Yeah, let's talk about the inference, because we just talked about this time series data and all this sort of stuff, right? What's really cool is now you have like you've built this agent, it's running, but now you have live data coming in, right? And so like are you real time streaming that back to the model to inference out? Like how are you kind of improving it?
One of the things we're experimenting with, and I think this is how we're thinking about especially code repair, is there's two modes of deployment. One is this active thing, where it's like, okay, there is an actual LSP error, the user has a very direct action of like they hover over the line and click say fix this. That's this active mode of like there's a request response kind of pattern. That looks very different from this agentic kind of thing, which is what we're going for, which is this automatic autocorrect kind of thing, which is like the model has been trained in a way where whenever there is an IDE event, it will package it into a piece of context which the model understands, and the model will have a prediction, right? And so it's continuously listening for these kind of packets to surface up from the IDE and suggest predictions, and then you have heuristics to basically say whether you want to do it or not, whether you want to apply it or not. And those are the two paradigms to serve in this way. We're extremely excited about the latter because that's the thing which speeds up. You're writing something, you're writing a new like a pedantic model definition at like line 30, and you have to change your type signature like up somewhere up there, and the model will automatically do it because it fixes it for you rather than you having to hover and click around. So those are the two broad ways to do deployment. The second one is what we're excited about, and the model has been like the modeling problem has been framed in this way that there's a one-to-one mapping of the IDE event to how it's packaged into context for the model, so it can predict it.
So if I were to ask it like differently, is it dependent on different use cases within Replit that sometimes inference may be done more in like a I'll use kind of like data streaming terms. Like, is it more in a batch term versus real time? Like, hey, this is we can't have any latency. This is going to be real time. We're going to adjust, and then like this is something that we could just improve on a weekly, monthly, whatever basis, and so we'll more batch it. Like, is that the right way to think about it? Or
yeah, totally, yeah. So there are these real-time inference kind of use cases where there's like these batch inference use cases. Majority of our use cases are in the former because you're editing codes, you're reindexing the REPL, you're recomputing embeddings, you're rerunning a program repair, you're rerunning code completion, and so on. So that's the dominant kind of things. And so we optimize for that. That's why we won't go with a very big model, which you can optimize, which is harder to optimize latency for because just the model forward pass takes so long.
Got it.
But that's basically the way we think about it. Stream versus batch. Majority of the user-facing cases are this real-time streaming kind of like patterns.
So here's a question just for you, actually. Like, how do you spend your time? Because like you said, every single day there's a new thing coming out. There's a new model. There's new agent techniques. There's new inference stuff, right? Like, how do you know, okay, this is something I should dive into versus this is something I should explore, or I'll put this on the back burner? What's your framework for that?
Yeah, no, that's a great question, and I kind of am pretty particular about this, but otherwise you get drowned in noise. So I think at any point of time, I have a list of problems in my head, and the list of problems go all the way from like Replit specific things, or like things I'm currently working on, things I will be working on in the future, or things I'm like interested in the back of my head. Maybe can this work out or something like that? And then obviously like more general things which I'm interested in. Oh, hey, I think there are a lot of these inference is moving very fast and performance is like increasing quite a bit. And so I have like a kind of a list of problem spaces in my head of what I'm interested in. And that acts as like this conditioning kind of like variable to like actually like whenever I consume information, I'm kind of like able to map it. I was thinking about inference deployment optimization at Replit. Oh, there's this new thing, maybe this can help, right? Like, I'm thinking about, like how do actually neural networks work at the end of the day? And so this paper comes out and I'm like, oh, okay, I will piece at that. And so I build this kind of index in my head. And based on that, I'm selecting what information I'm consuming. And in fact, based on that, I'm searching for information like of which I want to consume. And it just makes it a lot more cohesive because you're building very cohesive, like well linked together structures. Because like, okay, this problem, these approaches, these are the things I've tried. This is what is useful. This is what can create value for Replit users, and so on. So that's kind of my personal take. Otherwise, it's very hard, like because you could just given this fire hose of information, right? But that's my approach, and it's worked pretty okay for me so far.
Yeah, I mean, I can't even imagine because every single day on Twitter, it just seems like there's a new thing to think about.
Yeah, it's insane. Yeah, it's insane, totally.
But let's move into some of the future and around models in general. So right now, there's, I think OpenAI has talked about, they use that mixture of experts. I just saw there was like something called model merging or evolutionary models or something from this team out of Japan, right? There's multimodal models. Like, I guess in your day to day, do you use all the above? Are only certain of them applicable? Like, how do you kind of think about that?
Yeah, that's an interesting question because there's progress happening on different dimensions of the frontier, right? And so, which one do you catch? Which one do you leverage, right? And again, I think the approach is product driven or like problem driven first, which is like, okay, what are the suite of things you're trying to solve, right? And how do these things kind of help? So, okay, you're trying to improve model quality while controlling for inference. inference latency. Okay, mixture of experts works because okay, you have a higher parameter count, but you only have a subset activated at a time. So okay, that's one approach, right? Or you want to like get the most powerful model without spending the least amount of money on like fine tuning and so on. Okay, there's this thing called model merging, and you can do it. So that's the kind of like I encourage that kind of way to think about it because that it makes how you think about things very concrete. There's a flip side to it, which is like, okay, problem driven, like thinking about it is like you don't even know what you do not know if you're restricting to a problem sometimes, right? And so the other side of thing is like you have to the 20% of your time or 30% of your time is like you're completely just like exploring things and you're like it's that is non-problem driven, right, in some sense, which is like, oh, you're just like getting a sense of how it's there and you're like collecting new information and updating your model of how what the landscape looks like or what is possible with these things. And again, that becomes a sort kind of like index you hold in your hand and you can again retrieve from it whenever you're solving a problem. So those are the kind of broad approaches, like 70% problem driven, like know these new approaches, whatever you're reading, whatever you're consuming, you're able to map to it. And 30% is like unbounded exploration. And both are pretty important. I think you can't do one without the other, I think.
The next question I have for you actually is on multimodal, which seems like right now when I think code generation, stuff like that, I don't really think in terms of like images and videos and areas like that. And so maybe am I missing something there? Should I be thinking that way, right? Or is that something you're actively exploring of like, is there a usefulness to images and video?
I'll answer this question at two levels. One is the concrete level, which is like direct use cases and like the ways you can directly visualize and how it's useful. So, of course, front end development and human computer interaction and interfaces are a big component of software development, right? So, while I'm developing like a website, I'm actually rendering the website and like based on the visual, what I'm seeing visually, I'm actually editing my code and so on, like fixing CSS, adding components, and so on. And so the direct answer is that sure, multimodal models, especially ones which have an understanding in image space that influences how they write, like generate code and so on, are incredibly important, right? And Versal's doing pretty good stuff with V0 where they have text to image models and like the other way, which is like, okay, if I'm writing code completion and if I get some signal from what the code is rendering, that actually is useful. So those are the kind of like workflows which are obviously very common. The second level of the thing is this more like abstract level feedback, which is like, if you think about it, when human beings are working with like a code base and developing a piece of software, they're getting the signal of what they're doing on multiple different modalities, right? Not only are they saying like how fast is the code compiling, like whether whether it's breaking and things like that. A lot of it is visual because they're looking at the UI being rendered, they're looking at the logs, they're looking how the project structure and so on. So there is this high level kind of like global feedback loop or like information which is fed visually as well. So for example, while you're developing in a REPL or something like that, and there's an agent, if it sees the entire REPL and like how things are, where are you moving things around and what did you do last to, how is your UI rendering, that all is ultimately information because my claim is that human beings do it, like visually scope out like where you're looking and so on. So I think that is the other way. It's not very concrete yet. It's like how's actually like this cross modality kind of like global feedback signal coming in, right? But I suspect that will be a part of like kind of like more like complete end-to-end agent systems, even in software development.
That's interesting to think about. Like the agent is, yeah, because otherwise you're just feeding it the code base. Okay, great, it knows what the code. But now if it understands like the context behind it's a website and you're trying to do this code specifically for this chatbot that you want to embed in the
Exactly.
in the like there, that changes the component. Yeah, that's really interesting.
And one last thing is there is obviously the old school answer to this is a lot of like software development practices had communication around visual diagrams and so on, right? The whole world of the UML and so on. And it is visual representation of like systems and behavior of systems has existed. And I think that's a dominant way even most of us think about it, like when we're doing design docs or system diagrams and so on. And that is like global piece of information again, right? If an agent has to build like a suite of microservices and so on, there is some information if it knows the spec or the system diagram or like the sequence diagram and so on. So that's part of the boring answer. Like there is visual information which is useful as well in that sense.
Yeah, well, it's not boring at all. It's pretty fascinating. So, but we're starting to hear about like these new, what's next after transformers, right? And transformer based architectures. And so there's, I think Hyena, there's RWKV, these sort of different things. So, I guess how relevant to your research have they been so far?
I think they're more in the fundamental research direction, where we pay attention to these things, but it's not that we're going to run experiments immediately on top of it unless we have a reason. So, for example, like things like Hyena and so on, like the Mamba or space models, like they're solving for a very specific class of problems of like this, like subquadratic attention. And like for now, we're happy with like the kind of transformers we have and what code we're kind of using. Like it's not immediately like pursuing that experiment path is not going to result in a huge delta of like usefulness for our users. At the same time, there are some new like fundamental new things which come out, like like MRL embeddings and like binary quantized embeddings and so on, where that piques our attention, where it's like, okay, there is fundamentally something new here which unlocks like a high delta of utility for the user. And that's the thing we would bet on for doing research, for example. So yeah, there's a lot of moving parts, new architectures. We care less about the architecture, especially because it's not relevant to a problem, but we still care about certain kind of other fundamental research things which come out, which we can see how this can actually drive utility for a user.
I haven't heard about those embeddings that you mentioned, but is the general overview of those sort of things basically that they're helping solve that agent memory problem?
Yeah, exactly. So, like for example, like Cohere and then Mixbread, they have this like thing called binary embeddings, which is like instead of each embedding vector having one component in FP32, it's a binary 1 and 0.
Mm.
And then the claim is that they train the models in a specific way. The model generates these embeddings into FP32, which you can reduce down to quantize them to like ones and zeros into binary space while retaining 94% of the performance, right? So you make this trade-off. The big advantage of that is like you're decreasing your memory footprint by 32x.
Yeah.
You're removing the need for like complex like data structures like HSNW graphs and so on for like vector indices and so on. And that unlocks like certain useful properties on how you can actually build these things. And yes, of course, it helps agents because now you can query faster, you can query, not worry about costs of like how much information you're storing and so on. So that's a fundamental research kind of like idea, which we take and then we're like, okay, this clearly makes a lot of sense for us to experiment around and pursue and configure it and specialize it for our domain and use case.
Yeah, that's fascinating. We'll have to link to those papers in the show notes. But so let's move into kind of the Replit future, right? Because you guys are doing a lot of stuff. You're pushing the envelope. So right now, I guess you just shipped the repair agent. Should we be expecting kind of far more agent based type development in the future from Replit versus the so-called like co-pilot approach from like previous years?
Yeah, totally. And I think we've been doing like thinking about agents for a while. Like I think I did a hackathon last year where it's like I built this thing of like, oh, you give it a prompt and it gives you a plan and then literally SSHs and puts file in and so on. So that's obviously a direction which is promising for future software development, as you can see with multiple startups coming up and so on. I think doing agents in production at scale and doing them right is hard, and you want to really get that right. So we're spending a lot of time working on it. The big thing I would say just philosophically is like there are two kind of broad ways. I was talking to my coworker about this, like to think about agents, right? One is like, okay, very complex agent, very simple environment, right? So the agent has a huge prompt and, it has a lot of logic and like prompt engineer to actually like handle a lot of use cases and so on. But the environment is very simple where it can just like do like just output text or something and things like that. The other paradigm is like your agent is simple, but your environment is very complex. So your agent basically is just reduced to like actually effectively orchestrating the environment and using it correctly. At Replit, we're trying to like think about both, which is like, what does it mean to build like a highly capable agent in a highly complex environment like the Replit development environment, which is basically everything, right? And it's a hard design and engineering problem to actually get that mesh together well and actually be able to do things. Demo vaporware is easy, but like actually doing it at scale and doing it at the scale of Replit in a way which is useful for the user. Let's not forget that. That's pretty important. Yeah, we'll be spending time on that. And code repair agent is one direction, where it's like a small piece of like isolated vertical, which is like, oh, fix your code. But you're going to see more and more kind of like an agentic orchestration of your entire REPL from creation to deployment. And yeah, keep an eye out for that. I think that's going to be pretty exciting. We're pretty hard at work for that.
Well, demo vaporware in this environment helps you raise $150 million. So
exactly.
But
exactly.
So in terms of Replit as a whole, like the culture seems like from the outside that there is really really fast shipping cadence. I think you guys put out Ghostwriter. I want to even say like it was around the same time as GitHub Post. It might even before, but it was very quick, regardless. And then it started to improve, and it started to improve, and more stuff got shipped and stuff like that. So, what's happening? What's in the culture? What's in the water you guys are drinking that's like allowing this to happen?
I think firstly, I just think like the quality of people I'm very lucky to work with is like extremely high. It was like it's just a no brainer. Like you're getting some of like the best engineers and hackers, like very much hackers. Like my team lead was engineer number 7 at YouTube, early engineer at PayPal, and like this guy's an absolute beast. And like our CTO Luis, absolute monster. Like so, I'm a little biased in saying yeah. Like I think it's just a core talent. Engineers is a very high variance occupation, right? Which is like you can have 1x output or 10,000x output, if not 100,000x output. And Replit has like just the quality of people we have we have got together in a room is extremely high. That's of course a biased take, but I think it's a very accurate take. And more people don't realize that the answer might be as simple as that. It's like great people. The other thing is we're very small. Like we haven't grown for our the amount of users we serve. We're not like a massive big company. Like we're keeping it small. We're very careful about not just like unnecessarily growing, and it has to have a reason. And that allows for very fast communication and very intertwined communication. It's like you know exactly who you're working with, and you have this kind of like very established like kind of like personal practices of how you work with people, and I think that helps a lot. And lastly, I think it's just the fact that we're very engineer driven, which is like we care a lot about the kind of technical work we're doing. Everybody obsesses about it for a lot of detail. There is no like layers and layers of management. You can do whatever you want. You can ship other things. You can ship fast. You can get feedback. You can put things out there, and that's encouraged, and it's never shunned, even despite you growing. And we've done a good job of like maintaining that. We have these deep work days where it's like one day nobody's allowed to schedule any meetings because let the people, engineers and otherwise, do work, right? So things like that where you're actually prioritizing like engineering productivity is like incredibly important. Yeah, I think culture is one of the most important things to build, and that this hacker culture is very innate to Replit. People build things, people ship things. Oh, hey, I built this. What do you think? Just somebody puts it on Slack. They built it over a weekend. So many of people at Replit just end up doing like fixing things or trying things over weekends. And that's usually a very good sign of like people are actually caring a lot about what they do, and they're actually the productivity is not like 9 to 5 constraint or like manager constraint or things like that. So that's my take, at least.
Well, so for people listening, may not be hiring a lot, but if you see a role open up, it's a place you want to be.
No, of course, if you're good, people at Rappler will love you and welcome you with open arms. I think we're always like on the lookout for great people to work with us.
Back to the agents, the general question I would ask you is it easier in your mind to have, I'll call them dumb versus smart agents, for lack of a better word, but a dumb agent that's like really good at one specific task, and then, but if you have a bunch of those dumb agents, like maybe then you can you have low variance in terms of the errors? Or is it better to have a really smart agent that can go and iterate through and reason through a bunch of different things, but there might have more variance in the actions that it's doing?
Totally. Haven't made up my mind about that answer yet, but like I'll think about the trade-off out aloud. I think the way to think about agents correctly is not what the agent is, but what the agent does. So like if there is sufficient overlap in two kind of like tasks what the agent is doing, maybe there is like if there is value in having it to be like defined within one system with one workflow. You're also reducing engineering complexity in terms of maintaining a state and so on. But at the same time, if you can isolate very clear end-to-end well-defined workflows which are completely isolated in terms of state and like computation from other kind of parts of the system, then you want to probably isolate that and get a small thing and highly tune it for that particular task. There is obviously some research out there which is saying, oh, many agents outperform more than one, and things like that. I think it's more a property of what the problems the agent is trying to solve rather than what the agent is and how it's built. And I haven't fully made up my mind yet, but I think part of it's going to be that. At Replit, I think we're open to both directions where you might have a central orchestrator, right? And you have other sub workflows. The point is, it's again driven from the point of utility of what is actually doing, what is the problem it's actually solving, what's the trade-off in cost and performance to actually do it with one model, one system around a model, or actually like a shared system around a model. So it's a slightly messy kind of like engineering kind of analysis to do, but that's my kind of take. So yeah.
Yeah. We're going to link to a recent tweet thread that you had, that which was particularly fascinating. But you talked about how you think that models, kind of fine tuned by Replit, will soon be Replit IDE specific, and so they'll actually trigger workflows and actions directly in Replit. Like, kind of,
Yeah.
where are we? Is this happening tomorrow? Is this, and what do you mean by all that too?
Totally, yeah. And this is a little bit of a novel idea which I've just been thinking about a lot. So the current paradigm of agents, or building software which interacts with external systems, is like you have an LLM which is independent of a system, and then you're like shipping information between the context of the LLM, right? So you have running like React like agents like strategies, but in the prompt you're instructing it for tools and reflection and things like that. That's very much the current agent paradigm of around GPT-4 or around a big LLM, you're building your agent, right? The other thing which I've been thinking about, and that this basically came while I was working on the program pair thing, is like one of the things is when you're working on a concrete problem, you start to see how it generalizes to other things. It's like there is this notion of actually the data distribution the models are trained on are not things like text, where you're translating information into prompts and then feeding it the model, but rather you're packaging information up these packets of context, like the way function calling and tool calling have done with these tokens, and actually train your model to learn the distribution of the state, events, and action of your platform, right? And so instead of actually moving things and turning them into prompts and feeding it the model, getting them back out and parsing and so on, you're actually training your model to see sequences of these, like the entire state, events, and actions of the platform. What does that unlock? And so far, or with Procoder pair and so on, what we have shown is, okay, for this entire stream of my application, you can identify sub windows where, if you actually predict a model to actually predict those sequences and actually go and skip, instead of the user having to do actions, the model actually takes you from one state to the other. That's a clear product surface where it's like, okay, you solve errors, you solve debugging errors, you solve environment configuration, and so on. You can sample these different windows and do it. The other more general idea is actually, can you actually do it end to end, right? So it's like your prediction of the model moves from, rather than just doing the just completing the line of code, to actually the next action or the state of the ID, right? So can it, the question is, what can it represent the entire, how your application changes? So one way to visualize it, instead of just ghost text being completed, you're actually, the next ID in the action is being highlighted, right? Or the next kind of the file is being moved around on its own and things like that. And I think that is quite magical. What I'm particularly interested in it is what is the kind of novel kind of ability for these agentic systems that it unlocks, right? Sure, yeah, it sounds nice and so on, and but can it actually unlock fundamentally new capabilities? And one of the things we've seen is these transformers, when they scale to different kinds of data and different kinds of models parameter sizes, they learn very, very interesting things, right? And you have these emergent effects. So that's kind of the high level, just concept theory driven kind of way to do it. In practice, program repair is one instance of that, where it shows that it works well for a very use case, and you want to start generalizing it to these new tasks. So that's pretty exciting. I've been talking to a lot of people about it. I suspect that there might be something there in terms of how you do things. So
yeah, it's a fascinating vision, and it makes so much sense. And honestly, would whether it's Replit or whoever would really super charge that product. Flip side is, though, as I think about the data tagging and the semantic layer type stuff that you need to classify this function,
exactly.
it's a mind-boggling hard problem.
Exactly. It's purely a data representation and data infra problem. It's how do you actually turn your entire application into the stream of well-defined data stream, and actually be able to build data sets off it. So yeah, it's super interesting. Yeah, I'm pretty excited about that, to see where that goes.
Yeah.
More to know whether I'm right or wrong.
But I think what's cool is that it's that is not necessarily dependent on, if the data was structured that way today, you could probably do a lot of that. And it's not necessarily dependent on agents or transformer architectures or anything evolving. It's actually more of like a solvable thing where you just need to figure out a very hard data challenge. But if you figure it out, that vision probably could be brought about sooner rather than later.
Exactly. And yeah, one of the things we talk about a lot is like, oh, if OpenAI has taken everything in like text, video, audio, blah, 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 how do you actually build new things in this space, right? Or you're always susceptible to God Almighty GPT-4. And like, this is one way to think about it, right? Which is like, if you're running CAD software, can you actually get streams of like, how do you edit and actually build 3D shapes and actually train a model on that, right? And people have tried that in the past with this foundation model kind of approach, like adapt and so on. And I think there was something there, but I think focusing it on narrow use cases, and this unlocks a completely different dimension on how to think about building products with LLMs, right? Rather than just like prompt engineering and so on. So that's what I'm pretty interested in, and I think it's quite exciting. I think it's a promising direction. I don't know where it'll lead, but I think it's in a promising direction.
Well, with that, like, Madhav, thank you so much for showing us the future and also talking about kind of the state of the art stuff that you and the team at Replit are doing. It's truly fascinating. I guess to wrap things up, like, what would you like to highlight regarding Replit in the future?
One thing I want to definitely broadcast as a message is, one of the things I value the most about Replit is that it enables people who are not necessarily from a development background or software or like a tech adjacent background to actually come and develop. Like, so my granddad's a physicist and he's 83 and he's doing research in physics, and he uses Replit to run his C++ code, right? And like, that's the part which is inspiring to me a lot, which is like, anybody can build software. And like, that's the reason I joined Replit. That's the reason why we're doing Replit. And a lot of value, like our users who actually come back and tell us, hey, this is great, are people exactly who did not write a line of code or like are from different backgrounds, come in and actually build things very rapidly with AI. So just the message I wanted to share out there is, if you're trying to build software, like, this is probably the place you should go and try very quickly, because don't let anybody tell you that you need to go take a Udemy course in Python. You can literally just get started on day zero. Right. And that's what I would encourage. And I think that's what it's all about at the end of the day. If you have an idea, you go from idea to software fast.
Well, what an inspiring message. And I wish I had it in college, because, at my intro to Java class, coding Tetris was a lot more challenging than probably would have been with Replit today. So, but Madhav, thanks so much for the time. Really appreciate it.
Of course, my pleasure.